Video, we are finding the limiting reactant and the amount of excess reactant remains after the reaction stops, for which we will also have to determine the amount of excess reactant needed. Let's read the problem. The reaction between sodium and water produces sodium hydroxide and hydrogen gas. Well, there is no equation provided, so first you want to make sure that you have a balanced equation. So here you go. Here is a balanced equation for you. Let's read A. Determine the limiting reactant if 154 grams of sodium and 77.4 grams of water are mixed. So what are you doing here is, in this problem, this one, you are given 154 grams of sodium and 77.4 grams of water. We have to find out which one of these two reactants. So these are the two reactants, sodium and water. Here 154 grams of sodium or 77.4 grams of water is going to run out first in the reaction, meaning the reactant that will limit the amount of products. These are the products. So we have to figure out which one of these two reactants is going to be our limiting reactant. How much of the excess reactant remains after the reaction stops? So here we have to find out how much. So once the reaction stops, how much of the excess reactant still remains? So for that one, you have to subtract the amount of excess reactant needed from the available amount. You're going to understand that as I solve the problem. So let me show you, let me demonstrate this problem. How are you going to solve it step by step? Here you go. So let's assume that water is our limiting reactant and convert the given mass of sodium to the mass of water which is needed for the reaction. So what are we doing? We are going to convert the mass of one reactant to the mass of another reactant, and that conversion cannot occur directly, not in one step. It has to go through the mole ratios. So we'll be using three conversion factors. Here are the three equivalents for those conversion factors. This is the first equivalent. Second, this is the molar mass equivalent for sodium. This one is the mole ratio comparing water, moles of water and moles of sodium. And here is the molar mass of water. So let's start with the given mass of sodium. How much is the mass? 154 grams of sodium. All right. And then we have to convert this mass to moles. In order to convert the mass of sodium to its moles, we have to use molar mass. So here is the equivalent. Okay, since we are converting into moles, when you make a fraction using this equivalent, you are going to keep mass at the bottom and moles at the top. You cross out grams and grams because you need moles. So once again, you are getting this fraction from this equivalent, right? Just remember that. And this was our step number 1, where we converted the mass of substance A to the moles of substance A. Now we are going to use another equivalent ratio, which is going to come from this equivalent, and this is the equivalent for mole ratio that we are using. And where are these numbers? These numbers in the front coming from? They are coming from the coefficients of the balanced equation. Coefficients are these numbers which are written in the front. Here we are comparing the moles of water and moles of sodium. Alright, so for every 2 moles of water used or consumed, we need 2 moles of sodium. So let's compare this. Now here, what are you going to do? You're going to make a fraction. Now which one are you going to write at the bottom and top? So what goes at the bottom is the moles of sodium. Okay, and at the top 2 moles of water. So every 2 moles of sodium consumed, we need 2 moles of water. So in the second step, what did you do? You converted the moles of substance A to the moles of substance B. This is your substance B, water. Now cancel same units, moles of sodium, moles of sodium. Well, we are not finalized yet. We are only in moles, but we need grams. So our third step is to convert the moles of this substance B to its mass. We are going to use this third equivalent here. And what do we get? We know that 1 mole of water, this we already know. And to determine the molar mass of water, we have used periodic table. So 1 mole of water, 1 mole of water, okay, 1 mole of water is how many grams? 18.02 grams. Now guys, why am I writing grams at the top? Because this is what I want. I want the mass. So mass at the top and moles at the bottom. You cross out the same units, and also you can cross out this 2 and 2 because they are same numbers. Now plug in these values and you are going to get 120.65. 1, 2, 3, 6 fix, so 121 grams of water. Don't forget to write, besides the number, you should always write the unit and you should always write the substance. So we needed 121 grams of water to react with 154 grams of sodium. So this is what is needed in the reaction. Now, well, how much is provided in the reaction for this chemical reaction? We are provided 77.4 grams. Remember these two masses, these are already given in the problem. So we are given 77.4. That's the available mass of water. But how much do we need? We need 121 grams. So this is not enough. So available amount is less than the amount of water which is needed. So water will be our limiting reactant. And I'm going to write here for you guys, why is it limiting reactant? Because you need 121 and you are given only, so available amount is only 77.4 grams. So this is available, this is needed. Needed is more than available, so this is going to, so water is going to limit our reaction. Alright, now to figure out the excess reactant, in order to find the excess reactant, we are again going to follow the same steps. Now we are going to convert the given mass of water. So before we converted the given mass of sodium that was available to the amount of water that was needed, right? Now what we are doing is, now we are going to start with the given mass of water, which is 77.4. Okay, and then we are going to find out by using when 77.4 grams of water reacts with 154 grams of sodium, when this much grams of water is used, how many grams of sodium will be needed? This is what we are going to figure out. Okay, so same steps, you are going to convert this mass to moles, and this is water. For water, the molar mass right here, we use this equivalent fraction, 18.02 grams of water. That's the mass for 1 mole of water. Cancel the same units. The next step is you're going to compare the moles of water and moles of sodium. So here you are multiplying with the mole ratio. What do you know? What are you converting into? You're converting these moles of water to moles of sodium. So moles of sodium has to be at the top. So for every 2 moles of water consumed, every 2 moles of water consumed, every 2 moles of water consumed, we need 2 moles of sodium from here and here. That's where I'm getting these coefficients from. And guys, these equivalents will not be given to you. You should know how to write these equivalents and how to make fractions from there, and which fraction you should pick. You should always pick a fraction where you have starting unit at the bottom and ending unit at the top. Whatever is known at the bottom, unknown at the top. That's how you pick your fractions. Cancel moles of water, moles of water. And again, we are not going to stop here. We are going to convert this moles of sodium to its mass in grams. So we are going to use this equivalent from here. 1 mole of sodium contains how many grams? 23 grams. Okay, cancel moles of sodium, cancel moles of sodium. Similar units cancel. Also cancel this 2, same numbers in the numerator and denominator. When you plug it in, you are going to get 98.79 and grams of sodium. Don't forget the unit. So 1, 2, 3, you have 3 sig figs, so it will be, you are going to round off here at 7. And the next number is 9, so it is 98 98.8 grams of sodium, right? So this 98.8 grams of sodium is needed to react with 77.4 grams of water. All right. Well, this is what is needed. Let's see how much is provided. We are provided 154 grams. So available amount is more than what is necessary. What is necessary or needed or required is 98.8. So our sodium is excess reactant. All right, guys. So the last part is we have to figure out the leftover. How much is the excess reactant leftover at the end? So what are we going to do here? You subtract the needed amount of excess reactant from the available amount that is given in the problem. So available amount minus the amount needed. Okay, so what is available amount? 154, and the amount needed was 98.8. And again, don't forget, we are talking about the mass of excess reactant, and excess reactant is sodium. Sodium, sodium. When you subtract it, you are going to get 55.2 grams. Okay, so limiting reactant, excess reactant, LR limiting reactant, ER excess reactant, and leftover is right here of sodium. Alright guys, so here you go. Here are my quick notes for you. I know you have done all these problems in class, in breakout rooms, practiced well enough in class, but I still want you to pause the video and take time reading all these quick notes again. Here is another. I have also given you all those equivalents and the fractions that you could make from each equivalent and how you use them. I have highlighted, I have put all my notes. Please take time reading them, and again I have written the steps at the bottom. I hope the video was helpful. Thank you so much for watching, guys.